Hey again everyone, this is Martin, and this is part 9 of the C++ OpenGL FPS Game Engine / Game Devlog series. That's a big title. This is going to be a quick one, quick update on a couple of changes that I made over the past few days whilst I had a bit of time. Basically, memory allocation and deallocation tracking. So this was kind of inspired by a video by the Cherno, who does like an amazing C++ series, and it's just a fantastic channel. I'll put the link in the description, but there's the link. I've got commented as well. But what I'm doing here is overloading the new and delete operators in order to track the memory that is being allocated. So, for example, here on the new one, I've created this memalloc tracker file, which basically, well, adds the allocated memory. So if I go into here, all I'm doing is incrementing this static allocated uint32 over here, and when the memory is freed, for example, well, delete is called through the overload operator, then I'm just freeing this size down, and then all I'm doing is logging the allocated size in both cases. So total allocated minus total freed. So the idea being that you can see how much is being allocated on the heap at runtime, how much is being deallocated, is it going up, is it going down, but also to see where those allocations are happening as well. So I'll just jump in and show you. Hopefully this doesn't slow down the recording too much, because it was spamming like crazy, and it's going pretty slow now, I can tell, whilst I've got the recording on. I won't start the main scene, the 3D world, because that did take a while. But what I'll do is just let this run for a second, and then I'll quit out. So let's get out of there. And I just want to look at the log. So if I go way up to the top first, well, just logging, you can see what's happening. Allocating 16 bytes here. This is pretty early on in the execution. In fact, I think this is the very first line. In fact, I think it's got everything. But anyway, allocating 24 bytes, and the current usage is 24. Makes sense. Allocating 16, it's now gone up to 40. Allocating another 122, that's gone up to 152 bytes. So this is what is being allocated on the heap, not is what is being used in the stack. This is just heap allocations. But you can see here, like with 24, we've gone up to 1,888 bytes. Keeps on climbing, 3,000 bytes and so on, and eventually sort of caps out roughly around 1 meg there. So what I want to do is, that's after this 1 meg part here. If I just scroll up and down a little bit, you can kind of see like this 1 meg. Hopefully that's clear as I'm scrolling. We're capping out around 1 meg here, just with that initial scene running. Again, this is just as what has been allocated on the heap, not the total memory of the application. But this is what I can kind of control in terms of, well, we don't want to be allocating on the heap all the time, like a ton of times every frame. So here I've thrown in a little frame counter as well. And you can see sort of between frames 16 and 17, we've got a bunch of allocations here going on all the way down there. Now this is interesting for me. This is the first time I've actually run something like this and seen it in action, where I can say, all of these things are being allocated on the heap and they're being deallocated. Okay. Like this happens all the time, obviously, in applications, in game dev specifically. There's a lot of stuff that's created on the heap, but the idea is to keep it down to as minimal as possible. Part of my wanting to do this is that I need to handle the problem of memory increasing when I'm going back from the main game scene back into the menu. There's a memory leak going on, so the memory keeps on creeping up and up and up, and I want to track that happening, and then after that start to put in all of the destructors within each of the classes to see which ones are not getting destructed. So I could have probably done that first, to be honest, but I wanted to do it around this way anyway, because I thought it was interesting and I wanted to start to clear things up. So you can see kind of after frame 16 has been triggered, we've got 1090 768 frame 17, the same number. If I go down a bit, frame 19, 768. So we're not creeping up memory within that scene as it's just running on its own. It's just going over the update loop. But a lot of these are probably going to be, well, a few of them are vectors, and a couple of them are strings. So let's take a look anyway. If I go and let me just close this down, and what we're going to do to find out exactly where these allocations are happening, and again, this is all of this information was picked up from that Cherno video that I'll put in the description. Really awesome video. If I go into the global overrides, global operator overrides, and if I just put in a breakpoint here, in fact, what I'll do is I'll restart and then I'll put the breakpoint in afterwards, because then I can let the initialization just fire away and we can get into the meat of it. So let's just let this run for a little bit. Yeah, it's been a little bit slow because I'm recording, and this is a real potato PC as well. Okay, let's just put this in here and see what we've got. So, okay, looking at the stack frame, call stack here, if I go down to, yeah, the new operator was called, I think what I'll do is I'll just hide the external code for now, and I can see that this is coming from our draw command. So there you go. Use texture. So what's probably happening is, and I've already looked at this before, but we're using a string literal there. If I go to set uniform, go to definition, we're using a string reference. However, I think what this does is because it's string, even though it's a reference, at some point it needs to get allocated on the heap. So if I go to, again, where was it now? Show external code. And this is where it's getting called. There you go, basic string. And if I kind of go up the call stack, this is in the standard template library there, we've got new being called. So this all goes, yeah, this is all basically because it's calling a string and that's getting allocated on the heap. What I can probably do, I think I've got two ways to handle this, is I can use the set uniform parameter. I can, if I go to the definition again, I can use a const char pointer, or I can use a string view. I'll try both of these. I'm not going to do it in this video. I'll do it in the next one, and then I'll report back, so to speak. But that's one there anyway. So let's okay, that's an easy one to clear up. Probably these ones as well. I'm not sure, but let's just continue on the journey. Hey, see what we can get. Again, let me just hide the external code there under Q draw. Okay, these all calling the same. Okay, there we go. So UI collect. Let's see what that's got. Ah, there we go. So vector. Vectors are allocated on the heap. Now, what we're doing is we're collecting all of the UI elements within the scene. Now, it has to be dynamic because within any scene there could be any number of UI elements. What I can probably do is put this vector, in fact, I'm getting a little ahead of myself. Let's just confirm this. If I go to show external code again, UI elements container, go into there. Yeah, this is the vector class within the standard template library, and then I think here it's going to be calling the new operator. Yeah, so I'm pretty sure it's coming from that vector, and I'm fairly sure, even without reading through the call stack here, that vectors are indeed allocated on the heap. So what I can probably do is, well, first off, I could move this vector to be a member variable of this particular class, so that we're not calling vector each time. What I might be able to do is reserve a particular size. So I say, let's say 100 UI elements, and therefore the vector doesn't need to resize whenever a new one is added. Maybe I can do that, but what I'll do first thing is I'll just move this to the top of the UI input class that I've got here as a member variable, and then just reference that and then add to it. So that should help on that front. Let's see what we've got next. Again, let me, yeah, I can probably just see these myself. It's been called a few times. I'm looking down here, guys. Actually, I will turn this off just to make it a little clearer. You can see collect UI again. I think that's the... interesting. Okay, so collect UI. Again, canvas component collect UI. We were looking at this UI element component. So it looks like within the UI element or canvas system that we're doing this a few times. So that was that one there. Auto children element get owner. See, I'm not sure what this is. Let's take a look at the external code here. Show external code. We're pushing back. Oh yeah. So I think what this is, and again, this is my rough knowledge and what I've been following on the Cherno, again, fantastic series on C++, is as we are allocating to the, pushing back to the vector, because it needs to be resized, it needs to be allocated onto the heap and then expanded and then copied over. So I think that's what this double in place is here as well, potentially. I need to rewatch a couple of videos just to understand it, but just to make sure I'm clear on this. But let's say you get you define a vector, in C# line, it's kind of like a list. It's a dynamic array that can be expanded at runtime. If you don't initialize it with a size, the first time you add something, well, it gets allocated on the heap when it's first initialized. Then when you add something, because you've not defined a size, it then needs to allocate that space on the heap. The next time you add another thing, because it's not got enough space, it has to find space on the heap for the next element and then delete the old element, the old memory location that contained one element, copy that over to the new one, and then add the second element as well, if that makes any sense. I'm sorry if I'm making a bit of a word salad there, it's kind of late. But let's keep going anyway. So we've got UI element component again, UI collect UI. I'll just turn off the show external code. Collect UI again, I'm looking down here, so there's a lot going on there. Canvas component flush, probably a vector again. Render command UI, interesting. Let's see what we've got in show external code again. Render command UI. Source not available. Container. Okay, so it's probably, sorry, this is absolutely messy as heck here now, isn't it? I'll have to dig into that one separately. I assume it's a vector. This render command UI is probably, if I go to definition, shader program mesh, yeah, so potentially there you go, there's a vector as well, so it's probably that there. I don't know, I'll have to look into these more deeply to see what they have in them as well, but this vector here is, would generate a render command every single frame. And what I can probably do is, just cache this. Again, move this out of here, put it into a member variable, and then at the end of the usage, sort of clear, you see we're doing the submit command here, or whenever it's finished, I can just clear that out and then use it again. And then we're not reallocating on the on the heap every single time. Let's see if there's any more obvious ones or anything that's different, but there's definitely some improvements around the UI and render queue system that we've got here. So these are minor, like very small allocations. They wouldn't make a dent in terms of performance on like a newer machine, but I just want to keep things clean and optimal. 164 engine line run. There you go, another vector of lights. I saw this one the other day. Again, bring this out as a member variable of the engine.cpp class. In fact, I don't even think lights should be there really. I'll have a look at refactoring that. But the point is the same, that having it as a member variable within the class, and then also setting a size of it as well. Could potentially use like an array. with a given size, because you know the number of lights that's going to be in the world, you're not going to have thousands of lights, at least that's not the plan anyway. So I could just use like a normal C style array for that perhaps, so, and then that just holds the light data, maybe, let's see. Yeah, collect lights again, collect lights, yeah, render queue.draw. Yeah, so there's something different. There you go. So U projection as well. That's probably the one that we saw before. String literal. But if I go to definition, yeah, we're using the reference string name. But again, that allocates, because it's a string, it has to be allocated somewhere on the stack. So we can use either string view or const char pointer, I think, to avoid that. That's going to come in the next video. I'm going to see how much I can get this down in terms of the amount of allocations that we're getting. Should be pretty interesting. Again, I wanted to keep things clean. I want to keep things as lightweight as possible. I suppose part of this as well is well, like I said before, I need to make sure that when I go between different scenes, from say the menu to the from the menu to the game world, and then back to the menu, or back to a different game, a different level, and so on, that the memory isn't incrementing and incrementing. And one way for me to track that is to track, hey, are my allocations going up or down between those two scenes? You know, as I go between the menu to the main game, is this number getting higher and higher and higher each time, or is it coming back down to the same level, which ideally it should do. So that's kind of why I went this way around first, and then I'll add all the destructors in the next maybe a couple of videos ahead and go from there, and just make sure that, you know, it's looking good, because I want to build a stable foundation, and I think it's interesting. Anyway, I like this. I've not done this before personally, so I think it's pretty interesting. So anyway, I hope you enjoyed this. Any questions, comments, ideas, or things that you've maybe seen what I'm doing wrong, you know, I'm all open to feedback. So yeah, pop a comment. Anyway, cheers guys. See you in the next one.